What if the real driver behind decline isn't plaques, proteins, or genetics, but the slow loss of the brain's main antioxidant? The molecule I'm talking about is glutathione. And when brain glutathione drops, neurons don't just struggle, they become vulnerable. And that vulnerability shows up years before diagnosis. Today I want to explain why brain glutathione matters so much, what lowers it, what supports it, and why avoiding chronic metabolic stress is one of the most underrated brain protection strategies we have. So what glutathione actually does in the brain? Glutathione is the brain's primary antioxidant, not vitamin C, not vitamin E, glutathione. It controls redox balance inside neurons. It neutralizes reactive oxygen and nitrogen species. It protects proteins from permanent damage. It helps regulate inflammation, cell survival, and gene expression. And here's the key point. Neurons are uniquely fragile. They burn huge amounts of energy. They produce lots of mitochondrial oxidative stress. They are packed with easily oxidized fats, and they have lower glutathione levels than glial cells, which are immune cells in the brain. So when glutathione falls, neurons pay the price first. Glutathione depletion happens early. This is not a late-stage problem. The research shows glutathione depletion appears before neuron death, and it's been documented in Alzheimer's disease, Parkinson's disease, ALS, and multisystem atrophy. In Parkinson's, glutathione depletion in the substantia nigra shows up before dopaminergic neurons die. In Alzheimer's, lower glutathione in the hippocampus and cortex tracks with cognitive decline. In ALS, reduced glutathione correlates with disease progression. This is not coincidence, it's loss of redox control. So the brain struggles to make glutathione. Glutathione is made from 3 amino acids. Those are glutamate, glycine, and cysteine. In the brain, cysteine is the bottleneck. Neurons can't easily make it. They rely on transport, and that transport depends on one key protein called EAAC1. This transporter pulls cysteine into neurons so glutathione can be made. When EAAC1 function drops, neuronal glutathione drops, and oxidative stress rises. What inhibits brain glutathione? Well, there are several things that interfere with this system. Firstly, chronic metabolic stress, low energy availability, persistent fasting, chronic AMPK dominance, and ongoing stress hormones. These states downregulate growth, repair, and antioxidant pathways. Second is inflammation. Inflammatory signaling interferes with cysteine transport and glutathione recycling. And thirdly, the big one, mitochondrial dysfunction. More reactive oxygen species, more demand for glutathione, and less capacity to regenerate it. Fourth on the list is amyloid beta and neurotoxic proteins. In Alzheimer's, amyloid beta directly impairs EAAC1 function, so that's the transporter for cysteine. That blocks cysteine uptake, and it blocks glutathione synthesis. The reason why antioxidants don't fix this is where people get confused. So vitamin C doesn't fix this, nor does vitamin E, and neither does CoQ10. Why? Because the issue is intracellular glutathione production, not antioxidant intake. Glutathione barely crosses the blood-brain barrier. Oral glutathione is broken down. IV glutathione is rapidly metabolized. The problem is supply and regulation inside neurons. So what improves glutathione? The research points to a few clear principles. Firstly, support cysteine availability. This is why compounds like NAC can help in some contexts. They bypass the transporter bottleneck. Second, support astrocytes. Astrocytes are the brain cells that act as glutathione reservoirs. They supply neurons with glutathione building blocks. Healthy astrocyte metabolism matters. And third, avoid chronic metabolic stress. Neurons need energy. They need glucose flux. They need NADPH. They need repair signaling. Long-term underfueling quietly suppresses glutathione synthesis. Fourth, support redox signaling. Don't blunt it. Glutathione is dynamic. It cycles. It adapts. Chronic stress breaks that adaptability. So the real takeaway is that brain health is not just about removing damage. It's about maintaining redox resilience. Glutathione is the foundation of that resilience, and that foundation is built through adequate energy, adequate protein, low inflammatory burden, functional mitochondria, and avoiding prolonged metabolic stress states. This can also mean states where you have elevated stress hormones such as cortisol and glucagon. Neurodegeneration is not sudden, it's a slow failure of defense, and glutathione sits right at the center.